Hi, in this video, we're going to look more in depth into 3 of the 5 basic types of inorganic chemical reactions and look at how you actually figure out the products of each of those reactions if you're given the reactants. So we're going to do synthesis, decomposition, and then finally combustion reactions. So let's start with synthesis. Please excuse my handwriting. I will do my best to be as clear as possible. Synthesis reactions are sometimes called combination reactions, whichever term you prefer. And if you remember, a synthesis reaction, we're going to have 2 or more simple elements, usually, combining to make one product, usually a compound. Now, the only predict the products that we're going to do is if our A and B at the beginning are a metal and a nonmetal, and therefore our AB is an ionic compound in the end. There are too many possibilities if you try to make A and B both nonmetals. They can combine in different ways to make different ABs, and there's no simple way to really figure that out. So let's use an example here, a real example. What if you had potassium combining with chlorine, and you need to figure out the product? Well, a lot of people would just say, all right, I just squish them together. But this here, this ionic compound does not exist. When K is in an ionic compound, its charge is not +2, its charge is +1. Cl, -1. So let's actually get rid of this. And we have to think about, what does potassium look like when it is in a ionic compound, and what does chlorine look like when it's in an ionic compound? Well, potassium's in group 1, so it's got a charge of +1. Chlorine's in group 7, so it's got a charge of -1. And when you crisscross those, you get KCl. Now, this is an unbalanced synthesis reaction. We would need to put a coefficient in front of there to balance the Cl's, and then in return over there to balance the potassiums. This is our final balanced synthesis reaction. But the key here with synthesis is you have to think of each substance individually. And what would it look like? What does each thing have to look like if it's in an ionic compound in the end? So the only things that we're going to do is we're going to have metals, a metal and a nonmetal as our A and B, and our AB is always going to be ionic. Okay, let's try decomposition reactions. Decomposition reactions are usually unfavorable processes. They usually require energy to get going. All reactions require a little bit of activation energy, but these need a lot of energy always. Heat, electricity, light, sometimes a catalyst, something to make the substance decompose. Because as you might recall, when we're doing a decomposition reaction, we're taking one reactant and making 2 or more products, breaking it down. So if AB is a binary compound, binary ionic compound, it will break down into its constituent elements, the elements that make it up. For example, if we have calcium oxide, okay, calcium oxide, and we need to state what the product is. So this is all you're given. Well, I'm going to break them up. I'm going to put calcium in its free elemental form and oxygen in its free elemental form. So when calcium is by itself, it's Ca, oxygen, O. But we're missing something. Oxygen, when it exists in its free form, it's always O2. So you have to think, again, just like the synthesis reaction we did before, you have to think about each element individually. Now, this is not balanced. We can balance it really quickly here. We've got 2 oxygens in the product, so we're going to need 2 in the reactants. That changed the calciums, and that's your balanced decomposition reaction. All right? So you break it up into its constituent elements, and you cannot forget if you have a diatomic. That's the part that trips everybody up. All right, let's look at combustion. Predicting the products for a combustion reaction is pretty simple because most combustions are just synthesis reactions that have oxygen. So for example, actually we just did one a minute ago. Let's see if we can do another one though. What if we had rubidium and oxygen coming together? Rubidium and oxygen coming together. We know this is combustion because it involves oxygen as a reactant, but it could also be considered synthesis because these are 2 very simple elements that are going to combine to make one product. So we have to think to ourselves here, what does rubidium's charge look like when it's in an ionic compound? It's +1. Oxygen, -2. Crisscross those, you are going to get Rb2O. Now, this is not balanced. Let's balance it. We're going to need 2 rubidiums. Whoops. 2 oxygens and actually 4 rubidiums. Okay. There we go. So, this looks like just like a synthesis reaction. Just have to make note of the fact that you have to take each individual element separately and think about them separately. Here is a combustion reaction that should be super simple to complete. If I have, let's do, if I have C3H6 and oxygen, what are the products? We know it's combustion. It's got the oxygen. But look at this here. I hope you remember that this is a hydrocarbon. And when you react a hydrocarbon with oxygen, you're always going to get CO2 and water. Now, this is not balanced, and this one's a little bit more difficult to balance than some of the other combustion reactions you can work with. But, so we'll leave it unbalanced for now. But if you have a hydrocarbon reacting with oxygen, you're always going to get CO2 and water. So those are the easiest ones to complete. So those are the ways in which you would complete a synthesis, decomposition, and a combustion reaction. And I hope that was helpful.